In this class, we will discuss the Lissajous figure that is produced due to superposition of two simple harmonic motions having frequency ratio 1:2. Let us consider two simple harmonic motions described by the equations x equal to a cos omega t, and the other one, which is mutually perpendicular, by y equal to b cosine of 2 omega t plus delta. So this means the motions involved are perpendicular to each other, one along x and the other along y. The frequency ratio is omega is to twice omega, that is 1:2. Also the amplitudes are different. One has amplitude A, the other one has amplitude B, and they have different phases. They are superposed simultaneously on a particle the resultant motion will be obtained by eliminating t from the equations, t for time. From the first equation, we have cos omega t to be x by a, and the value of sin omega t is, as per the well-known formula, so it is 1 minus x square by a square whole under root. We now consider the second motion, that of y. Dividing by b, we get and we can expand it to end up with now cos of twice omega t can be written as 1 minus 2 sine square omega t, and for sine we can use this expression, and therefore we get one minus 2 is minus 1, minus minus is plus, so we have 2 x square by a square, or and sine twice omega t can be written as and instead of sine we can write this expression and instead of cos we have x by a. So now it is time to collect all the terms and write the expression for y properly. So y by b is equal to, instead of cos twice omega t we have this factor cos delta. Instead of sine twice omega t we have this factor, so it will be twice of this factor, and instead of cos omega t let us write x by a, which will be multiplied by sine delta. So this is what we have. Clearly, superposition of two simple harmonic motions having frequency ratio 1:2, which are mutually perpendicular, will lead to a Lissajous figure or Lissajous pattern that is described by this equation, and we will discuss various cases corresponding to various values of delta. Consider case 1 that corresponds to, say, delta equal to 0 or twice pi, and this means cosine of delta is 1 and sine of delta is 0. So this equation will not have this part because sine delta is 0, and we will have only this part. In other words, we have or let us bring 1 to the left hand side, and let us write it in a standard form as follows: x square equal to a square by twice b into y plus b. So we end up with this equation starting from this one for the case delta equal to 0 or twice pi, and this is the equation of a parabola. That would be inscribed in a box of length twice a and height twice b. And this is the x-axis, and this is the y-axis, and this is the origin having coordinates 0, 0, and the coordinates of this point is a, 0. This point has coordinate minus a, 0. This point has coordinate 0b, while this point has coordinate 0 minus b. This parabola has vertex given by x equal to 0. So for x equal to 0, we have 0 equal to a square by twice b into y plus b, and this leads to y equal to minus b. So the vertex has coordinate x equal to 0, y equal to minus b. In other words, this is the point and the vertex is here. Let us find two other points from this equation corresponding to, say, x equal to plus minus a. So we have plus minus a whole square equal to a square by twice b multiplied by y plus b. So a square and a square will cancel out, and we have twice b equal to y plus b, leading to y equal to b. So we have two coordinates. One is, say, point P having coordinate x equal to plus a, y equal to b, and another point is, say, Q, which has coordinate x equal to minus a and y equal to b. Earlier we had vertex v defined by 0 minus b, and now we have identified two other points. One is a, b, and the other one is minus a, b, and they are here, x equal to a, y equal to b. So it is this point, which is P, and the other point is x equal to minus a, y equal to b, which is this point, which let us call Q. And we are in a position to draw the parabola, which is and it will be traced in this manner. So this is the picture at delta equal to 0 or twice pi. This was the main equation, and let us discuss now case 2 corresponding to delta equal to pi by 2, at which cosine of delta is 0 and sine of delta, that is sine of pi by 2, is 1. Clearly the first term will be 0 and we will only have the second term, that is and squaring, we get so this is the equation that we end up with from this one corresponding to delta equal to pi by 2. And let us draw the curve represented by this equation as follows. The Lissajous pattern represented by this equation will be between a box of length twice a and height twice b, this being the x-axis and this one is the y-axis. This is the origin, x equal to 0, y equal to 0. So the coordinate of this point will be a 0 and that of this point will be minus a 0. Coordinate of this point will obviously be 0 b, and this point has coordinate 0 minus b. Now let us focus attention to this equation and let us put x equal to 0. The corresponding y that follows from this equation is y equal to 0. This means the Lissajous pattern would pass through a point whose coordinates are x equal to 0, y equal to 0. And let us call this point O. And it is located here. Next, let us put x equal to plus minus a by root 2 in this equation to get and then what we have from here is clearly a's will cancel out and we will have a 2 coming out, which will cancel this 4, and what we have is 2, and here we have 1 minus, again a's will cancel out, and we have 1 by 2, and this gives us 1. So y is plus minus b. So these values lead to 4 points through which the Lissajous pattern would pass, and they are x equal to a by root 2 and y equal to b. So this is one point, and let us call it point P. The other points are, say, Q. Now we take y is minus b. Now we take x equal to minus a by root 2. And now we take y equal to minus b. And we note that this a by root 2 is actually plus minus 0.7 a. So x equal to 0.7 a, this is 0.5, so this is 0.7 say, and here also this is 0.5, this is 0.7 say, and p will correspond to y equal to b for x equal to a by root 2. So this is x equal to a by root 2 and y equal to b is here, so this is a point which we get. And for the same x, we have y equal to minus b. So this is another point that we get. And this is P point. This is Q point. And for x equal to minus a by root 2, we are here corresponding to y equal to b. That is R point. So we are here. And x equal to minus a by root 2, y equal to minus b is this point, which is S. So the pattern will be passing through these marked points. To get a clearer idea, we have to search for more points, and let us do it. Let us find the values of y corresponding to x equal to a by 2 and minus a by 2. So for x equal to a by 2 plus minus, it follows from this equation that and this gives us a's will cancel out, 2 square is 4, which will cancel this 4, so we have 1 here. Let us write this 1 minus A's will cancel, we have 1/4, so that we get 3/4. So y is plus minus root 3 by 2 b, and this is actually 0.87 b. So these combination leads to 4 more points, and let us call them A, which is x equal to a by 2, y equal to root 3 by 2. Next point is B, and now y is minus root 3 by 2 b. Then we have C, x is minus a by 2, y is root 3 by 2 b, and finally, and D is y is minus root 3 by 2 b. Now let us identify 0.87 b in the y-axis. So this is 0.5, so this is say 0.87 b, and here this is minus 0.5, so this is minus 0.87 b. So accordingly, point A will be x a by 2 and y is 0.87 b. So it is here A point, and B point will be a by 2 minus 0.87 b. So this is B point. C point will be minus a by 2 plus 0.87 b, and D point will be here, corresponding to x equal to minus a by 2, y is minus 0.87 b. So the pattern passes through these crosses, and we are eager to know how much the pattern will move on the x side as well as on the minus x side. So that let us now put x equal to plus a and minus a and find the corresponding y. So for x equal to plus minus a, from this equation we have and this leads to, we see that a is cancel out, so we have 1, so we have 1 minus 1, so it comes to be 0, and therefore y is 0. And this suggests that we can think of 2 more points, say E, which is x equal to a, y equal to 0, and F, which is x equal to minus a, y equal to 0 also. And these correspond to a0 is this point, which is E, and minus a0 is this point, which is say F. We are now in a position to make a plot of Lissajous pattern by drawing a curve through the crosses, or in other words, connecting the crosses with a curve. And let us do it, and let us plot the Lissajous pattern starting from the point O and moving through all the crosses, that is joining all the crosses through a curve which will represent the Lissajous pattern. So this is how we draw it. So this is the Lissajous pattern, corresponding to delta equal to pi by 2. Let us now discuss case 3. Let us now consider case 3, where we take delta is pi, and so cos of delta is -1, sine of delta is 0, so that we no longer have the second term, but the first term will be present, that is and cos delta is -1, or let us put it in a standard form. A square by twice b, and this negative sign will be here. So this is what we get, which is obviously the equation of a parabola. And this parabola will be inscribed between a box of length twice a and height twice b, this being the x-axis, this is the y-axis, this is the origin, and the coordinates of these points are a0, minus a0, 0b, and 0 minus b. And the vertex is obtained by putting x equal to 0, and if we put x equal to 0 in this equation, we have y equal to b. So the vertex B has coordinates x equal to 0, y equal to b. And 0b is this point. So this is the vertex. And the pattern passes through this point. Think of some other points corresponding to x equal to plus minus a. And we have from this equation so a is cancelled out, and we have so y is minus 2b plus b, which is minus b, and this leads to 2 points, say p corresponding to x equal to a, y minus b, and q, x is minus a and y is minus b. And a minus b is a minus b, that is this point, which is say p, and minus a minus b, this is minus a, and this is minus a minus b, this point is say q. So the pattern passes through these crosses and it is a parabola, and let us draw it. And this is for delta equal to pi. Let us move over to case 4. We now discuss case 4, in which we consider the case delta equal to 3 pi by 2, at which cos delta is 0 and sine delta is minus 1, which when put in this equation we get the second term survives only, and sine delta is minus 1. So we have and squaring we get which is the same equation that we got for case 2, which was delta equal to pi by 2, and this is the equation. So for delta equal to 3 pi by 2, the Lissajous pattern will be same as that for delta equal to pi by 2, and this is the Lissajous pattern. One thing is to be noted that this equation is in the fourth power of x, that is, it goes as x to the power 4, and so this equation leads to a Lissajous pattern that consists of two loops. This is one loop and this is another loop, because the frequency ratio is 1:2. Hence 2 loops. We now show all the Lissajous pattern for the 4 cases in a single diagram as follows. Corresponding to frequency ratio 1:2 and represented by this equation. This is x and this is y. We'll show the Lissajous figures for delta equal to 0 here in this 2a by 2b box. For delta equal to pi by 2, we'll draw the Lissajous figure here in this box. For delta equal to pi, let us plot Lissajous figures here, and for delta equal to 3 pi by 2, we shall show it here, and these are the x and y axis. Now the plot. And these are the plots that we obtained, represented by this equation corresponding to frequency ratio 1:2.